The question is, could you explain the direction angle method of resolving a 3D force vector into components? We mentioned in another video that there are at least three different ways to find the components of a 3D vector: the projection method, the direction angle method, and the position vector method. So in this video, we're going to talk about the direction angle method. We also talked about how to define a three-dimensional Cartesian coordinate system. I'm referring to the video on the projection method. So if you haven't seen that video, I recommend that you do that first. There is a right way to do it, as in this picture, and there's a wrong way to do it, as in this picture. So let's talk about the direction angle method. Remember this picture, right? So basically a cuboid that's kind of drawn around a vector A that goes from the origin of this three-dimensional Cartesian coordinate system O to point B. Let's consider the triangle OAB. We also noted earlier that this line OA is perpendicular to the line AB. We further note that the vertical dimension of this box is AY, the Y component of the vector A. Let's for a second focus on this angle beta. Beta here is the angle between the vector A and the y-axis, right? Now considering this right triangle OAB, we note that cosine beta equals AO divided by BO, right? Adjacent side divided by the hypotenuse, right? So it will be AY over A. Supposing, say, we also know these other two angles, alpha and gamma. Just as beta is the angle between the vector A and the y-axis, alpha is the angle between the vector A and the x-axis, and gamma is the angle between the vector A and the z-axis. Now on the basis of this, we see cosine alpha is simply ax over A, and cosine gamma is simply az over A. Now rearranging these equations, we see ax equals a times cosine alpha, ay equals a times cosine beta, and az equals a times cosine gamma. In other words, we found the three components of the vector A. And therefore, vector A in its component form is simply this. Another key observation here is the following. If I were to factor out little a out of the three terms, I can write this as this, right? But you recall that vector A can also be written like this in terms of the unit vector u along the vector A. Now comparing this with this, we see the unit vector is simply this. So the angles alpha, beta, and gamma are the ones that are called the direction angles of the vector A. Cosine alpha, cosine beta, and cosine gamma are called the direction cosines of the vector A. We may not use this phrase direction cosine that much in this course, but in mechanics in general, it is used. Here in this course, we will use this description, direction angles. So to sum, if the direction angles alpha, beta, and gamma are given, you find the unit vector along A by this equation, multiply that by the magnitude of A, and you have the vector A in its component form.